Hello, my peeps, and welcome to another Power Packed Phillips podcast, baby.
Whatever.
Please take a moment to read your MSAs.
What?
Don't forget your new EOC review packet is due next Wednesday, February 20th.
Whatever.
We've worked out problems 1 through 8 if you have questions on them in Blackboard.
Uh-oh.
Today's podcast is going to be on Lesson 7.5, Special Types of Linear Systems, Part 2. Please write down this system of equations. Remember, by definition, a system is two or more linear equations. So please write down the system x minus 2y equals negative 4, y equals 1/2 x plus 2. Since I have a variable, in this case y, all by itself, I'm going to use substitution to solve this problem. So let's use the strategy of substitution. We are going to substitute in for y 1/2 x plus 2. So remember, 1/2 x plus 2 is like our peas and carrots. They travel together, so we're going to put parentheses around 1/2 x plus 2. It's a quantity, peas and carrots. So we're going to take out the y, put in the 1/2 x plus 2. We are substituting. Remember, they are like peas and carrots. They travel together, so we're going to put parentheses around them. Did you understand how I did that substitution?
Yes!
Alright, now let's solve the equation. I notice that I have the distributive property going on, so I'm going to distribute negative 2 with 1/2 x, and I'm going to distribute negative 2 with positive 2, distributive property. So I have negative 2 times 1/2 x. Give this a denominator of 1, top times top, bottom times bottom. Multiplying fractions ain't a problem. Negative 2 times positive 1 gives me negative 2 over 2. When I divide negative 2 by positive 2, that gives me a negative 1. And my dog follows me everywhere I go, so I get negative 1x. Now I'm going to distribute the negative 2 with the positive 2. Distribute the negative 2 with the positive 2. When I do that, it gives me negative 4. Now I'm going to rewrite the equation with the answers that we got from the distributive property. Rewrite the equation with the answers we got from the distributive property. So I'm going to take the distributive property out, and I'm going to rewrite the problem with the answers that I got from the distributive property. So I got a negative 1x, and I got a negative 4. Now I've rewritten the equation. I have an invisible coefficient of 1. I would do hearts and stars. I will combine like terms. These are on the same side. When I combine a positive 1x and a negative 1x, that gives me 0. So I'm left with negative 4 equals negative 4. These are the same number, so that is a true statement. What happened to my x's? They got eliminated, canceled, goodbye. Negative 4 does equal negative 4. That is a true statement. Anytime we have a true statement, we have infinite solutions. So please write on your paper that a true statement is going to give you infinite solutions. What do you mean by that, Mr. Phillips? Well, a true statement is infinite solutions. There are car accidents everywhere. They just go on forever. You getting a little tired? Well, a little bit of yodeling always helped wake me up.
Yolo, 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 yeehaw.
Or we could always take a brain break. The next time that you think you've had a bad day, it could be a lot worse. Ouch. Huh. I thought that guy was wearing a Titans shirt after they got smoked by the Bears earlier this year. Huh. Maybe it's just my imagination. Brain break, over. Same problem, second strategy, graphing. Please copy down the system a second time, and this time write strategy 2, graphing. We want to write both equations in slope-intercept form, y equals mx plus b. Notice that this equation right here is already in slope-intercept form. So let's change the top equation, which is in standard form. Nice! Swedish fish for me! This is in standard form. Let's rewrite it in slope-intercept form. I have an invisible coefficient of 1. Y is my tornado, so this is an imaginary spy for the positives. So we're going to subtract 1x on both sides. Oh, epic fail. These will cancel. Now I'm left with negative 2y equals negative 1x minus 4. I'm going to divide every term by a negative 2. These will cancel, kind of like the Celtics canceled doubles last night. Now I have a negative divided by a negative. A negative divided by a negative is a positive, so I have positive 1 over 2. My dog follows me everywhere we go. Meow! I mean my cat. I have a negative 4 divided by a negative 2. That's going to give me a positive 2. Now, we took this equation, which was in standard form, we rewrote it. The question is, what do you notice about both equations? Both equations are the same. So this equation right here was like the Transformers. Transformers, robots in disguise. Because it was in disguise, it really was the same equation. So last time we got a true statement, infinite solutions. If you decide to graph them and they come out to be the same equation, then we have the same line. If the equations are the same, you will get the same line. Same line is the same thing as true statements. If the equations are the same line, we have infinite solutions, car accents everywhere. So that's the second strategy. Instead of substitution, you can do graphing. You get the same equation, infinite solutions, car accents everywhere. All right, let's do a quick summary so we can go watch the Flyers lose.
Wow!
Please write down the summary on your paper. You will have one car crash if the lines intersect at one point. Please write the summary on your paper. You will have one car crash if the lines intersect at one point. Please write the summary on your paper. If the lines are parallel, you have no car crash. If the lines are parallel, you have no car crash. That's a false statement. And our last summary to write down. If the equations are the same, that was like our Transformers, robots in disguise. If the equations are the same, that gives us a true statement. You have car crashes everywhere. Car crashes everywhere. There's an infinite amount of car crashes. Alright, thanks for watching. I'm jetting out of here. See ya.